Hello, in this video I will defend the report 5 for assignment 5, module 14, network application communication. First of all, it's about what we'll learn in this module. First, it's transportation of data, then our TCP overview, UDP overview, port numbers, TCP communication process, then TCP communication process, related to the flow communication, and the last UDP communication. There is a quiz of the first step of transportation of data. This model provides a number of network application communications and covers key concepts and protocols in this area. By studying this model, you will gain a solid understanding of how applications communicate over computer networks. And then there is a role of transportation layer. Application layer programs generate data that must exchange it between source and destination hosts. Then there is a quiz of the TCP overview. TCP overview is transmission control protocol. It is a crucial protocol for network application communications. It ensures reliable and ordered data transmission between devices. TCP is commonly used for applications that require high reliability, such as web browsing, email, and file transfer. Then there is the UDP header. It's a class protocol, meaning neither the client for the server tracks and state of the communication session. If reliability is required when using UDP as a transport protocol, it must be handled by the application. And there is source port, destination port, lines, checksum. There is a UDP overview quiz. Then why we used UDP? It's that it offers fast and lightweight communication, unlike TCP. UDP doesn't provide reliability or error checking mechanisms. It's suitable for applications that prioritize speed, such as streaming media and real-time gaming. Then port numbers. There we see the multiple separate communications, and it's used both of them for TCP and UDP. We use the protocol numbers or port numbers to manage the multiple synchronous conversations. We got source port, destination port, then it's quiz for the port numbers, and see that TCP and UDP transport layers use port numbers to manage multiple and simultaneous conversations. The source port number associated with the originating applications on the local host, whereas the destination port number is associated with the destination application on the remote host. Then TCP server process. It's say that TCP three-way handshake and session termination process is each application process running on a server configured to use a port number. The port number is either automatically assigned or configured manually by the system administrator. Then there is a quiz checking the understanding of TCP communication process. TCP ensures reliable data delivery by providing mechanisms such as error detection, acknowledgement of received packets, and the retransmission of lost packets. It guarantees that data is received in the correct order and without errors. TCP also incorporated flow control to optimize data transmission between the sender and the receiver, preventing the overwhelming the recipient with more data than it handled. These services make TCP suitable for applications that require high reliability, such as web browsing, email, and file transfer. By utilizing TCP network applications can ensure that data is transmitted accurately and efficiently across computer networks. Then reliability and the flow control. There is we see that segments in the order to destination. Uh, the there is TCP, there is maybe UDP, or there we see the segments from 1 to 5, from 1 to 7, and there is a quiz. And reliability refers to the guarantee that data will be delivered accurately in the correct order. Transmission Control Protocol (TCP), a reliable and connection-oriented protocol, provides mechanisms such as acknowledgements, transmissions, and sequencing to achieve this. These features ensure that data sent from a sender is received reliably by the receiver, minimizing the chances of data loss or corruption. Flow control, on the other hand, manages the rate of data transmission between sender and receiver. It prevents overwhelming the receiver with more data than it can process. TCP uses a variety of flow control mechanisms such as windowing and the congestion control algorithms to optimize data transfer and prevent network congestion. Then the last of the Model 5 report is UDP communication. Uh, UDP is a low overhead versus reliability. As explained before, UDP is a protocol for communication that needs to be fast, like VoIP. The topic explains in detail why UDP is perfect for some type of transmissions. This we see the sender then data through to the network and to receiver. We don't see any checking processes. Um, then there is a quiz. And unlike TCP, UDP doesn't provide mechanisms for reliable data delivery, such as acknowledgement or transmissions. It simply encapsulates data into datagrams and sends them to recipients without correcting their arrival or order. UDP is commonly used for applications that require real-time or real-time sensitive communications such as streaming media, online gaming, and voice over IP. These applications prioritize speed and responsiveness over the potential loss of some packets. And understanding UDP communication is essential for designing and implementing network applications that require low latency and real-time interaction while accepting a certain level of data loss or out of the order delivery. Then we see the packet tracer, where we use and understanding how to use the TCP and the UDP communications. First of all, there is steps. In the step one, it's we configure the multi-server, then generate web HTTP traffic. Then step 3 is to generate the FTP traffic. They will have part 2 to examine the functionality of the TCP and UDP protocols. Um, then, um, by practicing with packet tracer, we gain a hands-on experience in configuring and troubleshooting TCP and UDP communication. And we can explore different scenarios and observe the behavior of these protocols under various conditions. This will enhance your understanding of how TCP and UDP work and help you develop the necessary skills for designing and managing network applications. Then we see the model quiz of transport layer. Then the second part of our video, it's assignment 6, modules 15, and network application communications. And what we will learn in this module, these titles, it's for application presentation session, peer-to-peer, web and email protocols, IP addressing services, file sharing services. Application layer. We have two type of models. First of all, it's OSI model, then TCP/IP model. In the OSI model, we have uh, 7 layers. It's physical, data link, network, transport, session, presentation, application, TCP. In TCP, we have 4 layers. In the network, in the first layer, network access, it's merged the data in the physical internet. It's network, then transport, then the last layer application. It's merged with session, presentation, application layers. And there we see the TCP/IP application layer protocols. There's name system, host config, email, file transfer, web. SMTP, it's simple mail transfer protocol. We use it to work with emails, updates, official protocol. TCP/110, it enables clients to retrieve email from a mail server, download email, and local the mail application to the client. IMAP, it's Internet Message Access Protocol. TCP/143 enables clients to access email stored on mail server, maintains email on the Internet. Then there is a quiz about understanding the application presentation and session layers. And in the OSI model, a TCP/IP model, the application layer is responsible for data exchange between programs and source and destination hosts. The presentation layer handles data formatting, compression, and encryption. The session layer establishes and maintains dialogues between application managing session initial continuity and the restoration. TCP/IP application layer protocol defines the format and control information for Internet communication function requiring compatibility between source and destination devices. Then client peer-to-peer. First of all, it's client server model, and in this photo we can see the how it works. First of all, we have a server, and for download some files from the server, we must have smartphone or something like that. Um, then peer-to-peer networks. It's when we have two clients and they are exchanged with files from other. Then peer-to-peer applications. It's client and server. Then client and server also also same. Then the quiz in the client server model, client requests data from the server, which responds with one or more data streams, and the peer-to-peer networks allow resource sharing without a dedicated server where each peer can act as both server and client. Some P2P applications combine the decentralized resource sharing with centralized indexes. Users share file pieces simultaneously using torrent files to connect directly to other users and local computers. Then web and email protocols. First of all, hypertransfer protocol in the hypertext markup language. It's HTTP and client, and it's how to work the internet. HTTP and HTTPS as its mean security. HTTP is a request response protocol. When a client, typically a web browser, sends a request to a web server, HTTP specifies the message types used for the communication. These will have 3 types of common message types like GET, POST, PUT. Then email protocols. One of the primary services offered by an ISP is email hosting. That we see how it works. Then there is a quiz of understanding different email protocols. When a web address is entered, the browser connects connects to the web services using the HTTP protocol. HTTP is a request response protocol with message types like GET, POST, and POT. HTTP encrypts data with the SSI mode for secure communication. Email protocols include SMTP for sending a probe and deleting from the server, and IMAP for downloading copies while keeping original on the server. Then IP addressing services. First of all, domain name system, and where we take the domain name system, it's works. Then then we have a genus hierarchy. The different top-level domains represents either the type of organization or the country of origin. Examples of the top-level domains are following. For example, commits mean a business or industry, or it's a non-profit organization. AU is Australia, and the point KO is Colombia. For example, in Kazakhstan we have point KZ. There is a root level domain, then all domains, and here the hierarchy. Uh, then there is usually a lookup command to understand and what we have, which IP we have. The dynamic host configuration protocol. In this uh, photo, we can see and how it works with client. Then there is we have a lab work. In lab work, we use ping with www.icon.org to determine our IP address, then in what time it's well done, and with which how much packets received and take it. Then we must use also with -4 to take it's in the IP version 4. In this part we use IP version 6. The, there is a quiz, and the DNS protocol matches the resource names with numeric network address using a message format for client queries, server responses, and record transfer. DNS organizes domain names hierarchically with each server manager a specific portion, and this lookup allows manual name server querying. DHCP automates IP version 4 address assignment, while the DHCP version 6 provides similar services for IP version 6 clients. DHCP messages include discover, offer, request, and reply. Then file transfer protocol. Uh, it's what can client upload data to the server and doing data from our server. Then server message block and how that works. This your file may be copied from PK to PK with Windows Explorer using the CMP protocol. Then quiz and FTP clients push and pull data from FTP servers using control and data connections on the TCP ports 21 and 20 respectively. CMP messages control messages, file and printer access, and application to device messaging in the file sharing, establishing long-term connections for resource access. Then the model quiz, and it's over.